Okay, so we'll start with radical equations. Now, when we do radical equations, basically we're taking the radical sign, but we're solving for x now. Right now we have an equal sign, now we're solving. But there are restrictions on the radicals. Think about this for a minute. Which part of this is the radical?
2x.
The 2x minus 1. Okay, so there's the radical right there. So 2x minus 1. That's the radical. What does that radical have to be? Why does it have to be positive? You can't take the square root of a negative number. Not yet. You'll learn in the future to do that. But can you take the square root of a negative number? No, you can't. Square root, I didn't say cube root. So what does this restriction have to be? It has to be positive. How do I write that mathematically to show that it's positive? Greater than or equal to 0. Could it be equal to 0? Yeah, you can do that, right? Okay. So solve for x here. So 2x greater than or equal to 1. X is greater than or equal to half, right? Is that correct?
You add 1 on the other side. And then
Really? I need to go back and explain that. I really have to do that algebra?
Would it just be max 1 and divide by?
It's just a half, guys. Okay, so x is greater than or equal to half. Okay. That's our restrictions, right? So could x be negative 2? Looking at this restriction. No. Could x be 0? No. Could x be a half? Yeah, because that would make that inside 0. Could x be 5? Could x be 6, 7, 8, 9, 10? Could it be anything? Okay, that's all our restriction is. We're just stating what the x could be. So when we finally solve this, we might get a weird answer. Yep. How do we solve this? Okay, let's go to the, I'm going to write the equation down again. So 5 plus root of 2x, oops, minus 1 equals 12. Okay. When you're solving algebra, what's some of the things you do when you're solving with algebra? What do you do? You always try to make the variable equal to something. The problem is it's not by itself, right? What do we got attached to it first?
We got 2.
I'm not talking about the radical itself, the other parts of it. We have a 5. Can we move that 5? What do we do with the 5? Put it on the other side of the equal sign. Okay, we put it on the other side of the equal sign. What do we get? 12 minus 5 is 7. Okay, now this should look familiar. What's the opposite of square rooting something? Squaring it. So could we square both sides? Didn't we do this in the last chapter? Yeah, we did. So we could take this thing and we could take it and square both sides. Isn't that correct? Square and square. Okay. What happens when you square the square root of 2x minus 1? You get 2x minus 1. What happens when you square 7? 29. Oh, wow. All right. This is looking better already, isn't it? Okay. Move the 1. 2x equals, the 1 goes to the other side, becomes 49 plus 1 is 50. Oh, we divide by 2. What does x equal? 25. Now, something you have to do, and this is beyond regular math, this is beyond 9 and 10. When you get an answer now, sometimes you're going to get extraneous roots, aren't you? What are extraneous roots again?
It doesn't work.
It doesn't work, right? But you still need the answer to do the math. Could this be an extraneous root? It could. We don't know. How do we check? You take it, you plug it back into the original. Okay, so we're going to check to see if x equals 25 as an answer. So check x equal to 25. Okay? So we go back to the original equations, which is 5 plus root of 2x minus 1 equals 12. So wherever we see an x, what are we going to replace it with? 25. 2 times 25 minus 1 equals 12. What's 2 times 25? 50 minus 1 is 49, so 5 plus the root of 49 equals 12. What's the root of 49? 7. So 5 plus 7 equals 12. What's 5 plus 7? 12 equals 12. Is that true? We did it right. What if it didn't equal the left and right side? It'd be an extraneous root, right?
So if it wasn't 12 equals 12,
It'd be wrong. Yeah, well, you could get, that could have been the answer. The 25 could have been the answer.
if it equals 20, then it has to be 20 over 1.
Okay, yeah, but if it was like 20 equals 12, then we know that that original answer was wrong. It's an extraneous root. You'll see in a minute. I'm going to give you an extraneous root right away. Guys, quiet, please.
So the number is supposed to equal 12.
Well, it has to equal whatever it's equal to on here. Okay. Now look back at what we did here, guys. Look. To solve this is really quite easy. Think about what we did here to solve this. What did we isolate? What did we try to get by itself? Not just the x to start with, but the whole radical first. Didn't we try to do that? You try to isolate the radical by itself. Then, if you square it, does it get rid of the radical symbol? Did it? When we squared it, did it get rid of the radical symbol? Yeah? Okay. Keep that in mind for the next one. Here's the next one. State the restriction. Which part of this is the radical?
5 minus n.
Okay, so 5 minus n. We have to state a restriction. 5 minus n has to be what? Positive. So how do we write that as math? Greater than or equal to 0. Is that correct? Okay. So that's our restriction. So
But it can be less.
I know. Okay, so let's do the math here. Negative n greater than or equal to 5. Now what do we do? Divide by negative 1. Oh yeah, negative 5, sorry. Divide by negative 1. Now, what do you remember though? No. What happens to the inequality, guys? Changes direction, doesn't it? Why does it change direction? Guys, when you divide or multiply by negative 1, or any negative number, what happens to the inequality? Does it flip? Yeah, you should remember that. That's from grade 9. Yeah, you guys have. Look, when you divide by negative 1, in this case, right, the negatives cancel out, you have to realize that when you multiply, or I'll put it in here, when you multiply, or divide by a negative, you flip the sign. You flip the inequality. You guys remember that? You should remember that. Yeah, you know what? If you're in grade 11 pre-cal, you were taught this stuff.
Well, we can't remember every single thing.
Okay, so this flips. Now think about this for a sec. N has to be less than or equal to 5. What if it was 5? What's 5 minus 5? 0, square root. Now, 5 minus 4. Does that work? That's still a positive number. Can you take the square root of a positive number? Yes, you can. 5 minus 3. You end up with 2. Can you take the square root of a positive 2?
Yeah.
Yes, you can. But what if it was greater than 5? What if that was 6? What's 5 minus 6? Negative 1. Can you take the square root of that? No, not yet. Okay. You'll learn this in grade 12. Okay. So our restrictions is n has to be less than or equal to 5. It's just good to know that. Now, how are we going to solve this baby? We're going to isolate the radical to start with. Okay, so let's do that. Let's isolate the radical.
You take the answer.
Hang on. Let me write the formula down first. N minus root of 5 minus n equals negative 7. Okay, you want to isolate the radical. So what do you got to move first?
And
You got to move the n to the other side. Bang. So let's move it to the other side. But in this case, hang on. If we move the n to the other side, we're still going to end up with our negative radical. Ooh. I don't like that. Makes my life difficult. Yeah, move the radical to the other side and move the 7 to this side. Does that make sense? You sometimes do that in math, right? You move things around opposite to what you think, just so you end up with positives, right? So in this case, I would move the radical to the right side and move the negative 7 to the left. Can you do that in one shot? Basically what happens to the signs, they just switch. Okay, so n plus 7 equals, what's on this side? 5 minus n. Is that correct? Yeah, it actually worked out really nice in this case. Okay, now what do you do? We've isolated the radical, now what do we do? Keaton, when you move a number or anything to the other side, the sign changes. So if this is negative 7, when it moves to the other side of the equal sign, it becomes positive 7. Right? If you move this negative over to the other side, it becomes positive. Right? It's just basic algebra. Yeah, we did this. We moved them both, right?
How come the 5n become a positive?
It did. It was negative, it now became positive. You treat that radical as a whole unit. You treat it as a whole unit. Okay, now what do you do, guys? We already isolated the radical. What are we going to do? How do we get rid of the radical symbol? We square it. If we square the right-hand side, what are we going to do to the left? Square it. Doesn't change. Oh, look at that. Is that a binomial? Is that going to give you a trinomial? Yes, it is. So n squared plus 14n plus 49. Did I skip the middle step? Did I combine the 7n and the 7n? Yeah, you guys are getting better with that. Equals, what's on the right-hand side? 5 minus 7. Okay. So we got a trinomial on the left and we got a binomial, well, we got some stuff on the right. Binomial, right. What are you going to do? I get rid of the 5 and the negative n and make it all equal to what? 0. Ah. Okay, we're going to bring all of the stuff on the right over to the left and we're going to make it equal to 0. So n squared. We bring the n over, it's negative n, we bring it over, it becomes positive. 14n plus n is 15n. The 5, it's positive, we bring it to the other side, it becomes negative. 49 minus 5 is, what is it? 44. Equals 0. Okay, now, we're solving for x. I've taught you a number of different ways to solve for x. Which one will always work 100% of the time? Quadratic formula. Could you do it in this case? Why not? Let's try it. Without all the singing. Okay. Now guys, there's really two methods to solve this. I'm going to show you both. Because what's going to happen is you're going to start to see patterns, you're going to start to see ones that work really well. So you want to do, which one do you want to do first? Quadratic? So let's do quadratic. So this is method 1. Method 1. We're going to do the quadratic. So first thing we should do is write down the formula. It's always a good start. X equals negative b plus or minus b squared minus 4ac all over 2a. Okay? Now what should we do? No, we should write down what we know, not put in what we know. What are a, b, and c? And now first off, is that in standard form? Oh. Does it always have to be in standard form? It always does. Okay, so what's A is 1, B is 15, C is 44. Now that you've written it down, can you plug it in? Sure, why not? Just continue doing the math. You guys have this. I'm going to write it on the board, but you know how to do quadratic formula. You just wrote a test on it, so.
That's not sure. 20 bucks, huh?
Guys, can you do this, please? Thank you. Oops. Would help if I actually wrote over. No. Is that yours? Whose is it?
Thank you. They put it over here.
Yeah, don't drop it on the ground either. Give me something of value you can have a calculator. Okay. Over 2.
44 equals 45.
Did you get this answer, or are you going to talk instead of doing it? You already have the formula. You know what A, B, and C are. No, you don't need to look. You can just do it. Come on. You know what A, B, and C are. Well, what do you get as answers? Did you get the square root of 49 underneath the brackets, underneath the radical symbol? Okay, look, you made the classic calculator mistake. Negative 15 subtract 7 divided by 2. What's it going to do first? It's going to do the division first, right?
Yeah.
So when you do your negative 15 minus 7, what should you hit? Equals, and then divide by 2. That is a classic calculator mistake. Okay, so you get two answers, right? You get negative 4 and negative 11. That's one method of doing it, is with the quadratic formula. Now, obviously, is there another way to do this? Do these answers actually work out quite nice? Do they? So the other method in this case, method number 2, we'll just go back up the top here. Method number 2, and there's always, I guess there's always easier ways, I think of it. What is it? N squared, what's the original? Plus 15n plus 44. Oops. Equals 0. Could you, if you wanted to, try to factor this into two binomials right off the hop? You should always try that first before you automatically go to the quadratic formula. You may save yourself about 5 minutes worth of work.
But it still, quadratic formula works every time. This doesn't work.
No, but you still should try it for starters.
But then if it doesn't work, go to the quadratic formula.
Yeah, I know, but if it does work, you've just saved yourself 5 minutes. But if it doesn't work, you've wasted probably 30 seconds. Okay, what times what gives us n squared? N. Okay. What does this second positive mean? They're both the same. We looked for the first one, and they're both positive. Okay, I'm looking for two factors of 44.
11 and 4.
Oh my goodness, 11 and 4, that when added together give you 15. Oh, 11 and 4. Okay, cool. So 11 and 4. Now you know, we just split them, right? N plus 11 equals 0. N plus 4 equals 0. So n equals negative 11. N equals negative 4. Oh, wow. Well, that was tough. Okay. Now, does it matter to me which method you use? No, but you should start thinking. You should start seeing these shortcuts. So we ended up with two answers. Now go back to our restrictions. N less than or equal to 5. So could those both possibly be the answers? Yeah, because they're both negatives. How do we check to see if they're answers? Look, we have two answers, negative 11, negative 4. Are they both correct?
Yeah.
Are you sure?
No.
You got to check both of them. Okay, so we got to check both of them. So now we need to check. What's the first one? X equals negative 4 and X equals negative 11. So you got to check both of them. So you got to take them and plug them back into which formula? The original, right? You got the original equation. Sorry, not formula. The original equation. Okay. What is it? N minus. Oops. If I could write down the right equation, that would help. Do the what? No, you just plug them in. We're not switching anything around. You're just plugging them in. So, negative 4 minus 5 minus negative 4 equals negative 7. Negative 4 minus, what's 5 minus negative 4? 5 plus 4, which is 9. Square root of 9 is 3. Negative 4 minus 3 is? Negative 7 equals negative 7. Is that true? Last time I checked it was true.
That's the answer, the other one's not.
We don't know. You could have 1, 2, 0. We could have multiple answers. Negative 11 minus 5 minus negative 11 equals negative 7. Right? You have to show this. You have to show whether or not it's the correct answer. Negative 11 minus... Hey, what's 5 minus negative 11? Positive 16. Square root of 16 is 4 equals negative 7. What's negative 11 minus 4? Negative 15 equals negative... Is that true?
No, sir.
No way. So what is that x equals negative 11? This thing here then is known as an extraneous, I'll get out of the way in a sec so you can see the board, extraneous root. That thing right there is an extraneous root. Oh, I forgot a T. Extraneous, there we go. Next question. These questions now now you're getting into pre-cal, where the questions are going to start to take quite a bit of space. Nope. No, some of them are good.
Yeah, some are really confusing.
Okay. Nope, not at all. Okay, you guys got this one? Can we move to the next one? Okay, now, this one's going to throw you. Why is this one going to throw you? There's two radicals. Now, guys, please listen. Please, this is a very important concept. If you miss this, you'll probably fail.
Are you joking?
How many radicals in this first one back here, the previous page? How many radicals? 1. So how many times did we square it to get to the answer? 1. Do you want to take a guess here? How many radicals do you see? How many times do you think we're going to have to square this to get to the answer? 2. So if you see a question like this where there's 2 radicals, you're probably going to have to square it twice to get to the answer. If you see one with 1 radical, you're probably only going to have to square it once. Is that it? You're not going to get that. That's why you're missing stuff when you have your iPod in. Yeah. Both. Oh, earphones right out, please. Guys, you shouldn't have iPods in while I'm teaching. Okay. Now, the thing is, you have 2 radicals, you're going to square this twice, and I already told you the key is to get these radicals by themselves, right? Well, it's going to be hard to do with a radical like this. So which radical, when you look at that, do you want to get by itself? Yeah, probably it's the harder one there, right? It's the binomial part of it, right? So to get that one by itself, what do we have to move? You've got to move the 5 to the other side. Is that correct? Okay. So if we move the 5 to the other side, it becomes negative. So 7 minus 5 is, so 2. No, because look where the radical symbol is. It stops at the 4, right? It doesn't go all the way over that, does it? Right? It stops at the 4. The radical itself is the 5x plus 4. Okay, so we move that to the other side, so we're left with 5x plus 4. Okay, that looks a little better, right? We went from 4 terms down to 3. I move the 5 to the other side, it becomes negative 7 subtract 5 is 2. Sorry, what? No. Okay. Because if we move the 3x to the other side, we're going to have double radicals, and then we got to do FOIL. And that is just nasty. They're two separate things. Those are not the same. No, you can't, because there's a 5x plus 4 there. That was multiplication, by the way. That was multiplication we did that in. This is addition, subtraction. Okay. Can we square this side now? Can we square that? If we square the right-hand side, will that get rid of the radical? Yes, it will. Okay, so if we square that, we're going to get a beautiful 5x plus 4 on this side, all right? It's lovely. Everybody's happy. But the thing is, if we square the right-hand side, what do we got to do to the left? Ah, dang. Okay. Now, this is a little trickier, because do we have a binomial with radicals in there? Are we going to have to FOIL it? Yeah. You can't do that. It's two binomials. You have to do FOIL. No, you're forgetting your basic rules of math. Okay, please say. Now, guys, if you're going to make this mistake,
If you just square root the 3x, doesn't get rid of the thing anyway?
yes, but we're not. It's 2 plus 3x.
You're squaring the entire thing, so when you square the 2...
Okay, look. If you wrote this out the long way, which I recommend you do because you're going to make this mistake, I can see right now you're going to make it. That's what that looks like, right? The 2 plus root of 3x squared, isn't that what it means?
Yeah.
Isn't it two binomials?
Yeah.
The perfect square, right? Not a difference of squares, but a perfect square. When you see that, what do you have to do? You have to do FOIL. It's not, don't do that, what you're trying to do, 4 plus 3x. Don't try to do that. That's what you were trying to do. That was, remember when we did mental math, were some of you making that mistake originally at the beginning? Oh, yeah. Okay, so we're going to FOIL this now. So really guys, FOILing this one's not that bad. So let's start with the 2 times 2. What's 2 times 2? 4. We're going to do all the steps for this FOILing, just to make sure you don't miss this. So that's first, let's do outside. 2 times 3x. 2 times 3x, isn't that right? Just multiply them together. Okay, that's first, outside. Let's do inside now. Oh, this one's backwards though, 3x times 2. It's 2 times 3x, guys. You know that multiplication doesn't matter the order that you do them in, right? So this was 2 times 3x, which is 2 root of 3x. This is root of 3x times 2, which is still 2 root of 3x. Isn't that correct? Doesn't matter the order. Why did I do them that way? So then I can combine them. Okay, now this one is going to throw some of you. 3x, root of 3x times root of 3x. 3x, right? It's basically taking root of 3x and squaring it, isn't it? So what's root of 3x times root of 3x? 3x. Okay, what's left over on this side? Okay. Okay, now, that's a bunch of garbage up there on the board. What do we got to do? We got to combine all the stuff that's the same, right? So let's combine some of this stuff just to make our life a little easier. So 4, okay, now, 2 root of 3x plus 2 root of 3x. Root of 3x. That doesn't change, right? That's our addition. That rule is still the same. So 3x. Plus 3x equals 5x plus 4. Now, the issue here is we still have a radical in there, don't we? Hang on. When we did this originally, we had a radical in there. What did we try to do? You try to isolate the radical by itself. Can we do that in this case? Can we get the radical, which is the 4 root of 3x, on the left side, and can we throw everything else over onto the right? Let's do that. That sounds like a good idea. Okay, so we end up with 4 root of 3x on the left. We move the 3x over to the other side. It becomes negative, right? So what's 5x minus 3x? 2x. We have the 4 over here. It goes to the other side. It becomes negative. 4 minus 4 is 0. Oh, well, that's easy. Now what do we got to do? Do we have to square it again? Didn't I say at the beginning, if you have two radicals, more than likely you're going to have to square it twice? So we're going to square the whole thing again. Square the left side, we square the right side. Okay. Now, this is where many of you are going to make a mistake. That one right there, 4 times root of 3x. No, it's a monomial, right? It's one whole chunk.
When you just square 4 and 7 8 plus 3x.
Well, if you square 4, it's not 8.
16.
Okay, 16 times 3x. Where are people going to make their mistake? Yes. Oh no. This is what some of you will write. Oh, you'll get the 4 and you'll go like this. Oh yeah, okay, because I took the square root of the square root of 3x, right? And you get that. That's where you're going to make the mistake. What do you forget? Yeah, you forget the square of 4, right? That's where you're going to make your mistake. I've seen it so many times. You have to remember you're squaring the whole piece, right? So 4 squared is 16. 3, the square root of 3x squared is 3x. Okay, 2x squared is 4x squared. Some people forget that coefficient. Common, I see it all the time. Okay, what's 16 times 3x? 48x equals 4x squared. How do you solve this? When you going through puberty, my voice cracks. Nice. Divide by 48. Why would you do that? You could divide by 4 if you wanted to. Would that help? Divide everything by 4 if you want. No. We'll get to the x in a sec. So what do we get? 12x equals x squared. Now, if we want to solve this, what do we normally make this equal to? No. 0. Don't we normally make it equal to 0? Okay. Now, here's a question for you. You're going to move the x squared over to this side, you're going to move the 12x over to the other side. Why the 12x? So, right, so we don't get the negative there. So x squared minus 12x. Okay, now, normally you get a trinomial there, right? Do we have a trinomial in this case? No. We don't even have a difference of squares. No. So now you look for a 3 letters. Starts with a G, ends with an S, has a C in the middle. Yeah. You guys missed that joke completely. Okay, what's common to both of those? X. What's left over? X minus 12. Okay, can we split this into its 2 pieces? What are its 2 pieces? 0 equals X and 0 equals X minus 12. So what does X equal here? 12. Okay, we have 2 answers. Could they both be solutions? Yes, they could. Could they both not be solutions? Yeah, sure, why not? How do we check? You got to take each one, and you got to plug it back into the original. Now you got to do it. So you left yourself some room. This might throw you sometimes when you get these simple ones, right? You have to realize GCF is always the first thing you look at, right? If you have a trinomial, more than likely the trinomial will factor into 2 binomials. But if we start with something other than a trinomial, you have to either look for GCF or difference of squares, right? Remember x squared minus 9? Remember those are difference of squares, right? If not, then you can go to the quadratic formula. Okay, so our 2 answers are 0 and 12. So now we're going to check. Yep, ask away.
I don't understand.
Which part?
Are you asking like 0 equals X, make it like that?
This?
Yeah.
We just split it. Like, look on the previous page. Hang on, where is it? Look, right here. N plus 11 and times n plus 4 equals 0. So we just split them, right? So n plus 11 equals 0, n plus 4 equals 0, right? You see that? And then we just solve for n. You just move the 11 to the other side, you move the 4 to the other side. Right? You know how to do this, right? This on this page is the exact same thing. Oops. This right here is the exact same thing. So one of them, we make x equal to 0. There it is right there. X equals 0. And the other side, we make 0 equals x minus 12. Then we bring the 12 over to the side. Right? All we're doing is doing basic algebra. When you get this and you get it equal to 0, you just split it into the two things. Okay? So let's check here. So we're going to check, what's the first one we're going to check? X equal to 0 and x equal to 12. Okay, I'm going to write down the original equation and check both of these. There we go. The original equation is 7 plus root of 3x equals 5x plus 4 plus 5. That's one of them. I'll write it down again. I'm running out of room. Yeah. So we plug in 0. So 7 plus 3 times 0 equals 5 times 0 plus 4 plus 5. Wow, this one's actually quite easy with the 0, isn't it? While you're writing that down, I'll do the other side here. So 7 plus root of 3 times 12 equals 5 times 12 plus 4 plus 5. The board, as it gets to the farther right, it gets really out of alignment. It goes off by a couple inches at least. That's annoying. Okay, 3 times 0. 0 squared, so that's 7. Okay, that 5 times 0. 0 plus 4. Square root of 4 is 2. 2 plus 5 is. All right, that one work. Yeah. 3 times 12. 36, square root of 36. 7 plus 6 is 13. 5 times 12. 60 plus 4. 64, square root of 64. 8 plus 5 is 13. Do they both work? Okay, so hang on. So guys, if you see one radical in the equation, the key is to isolate it, right? Get it by itself, get everything else on the other side, then square it. Okay? Then you're finally going to get down to the answer. You're going to look for GCS, you're going to look for factors either by a trinomial factoring into 2 binomial or a quadratic formula. Okay? If you have 2 radicals, you try to isolate one of them by themselves, square it, move things around again, and then square it again. You're going to probably have to square it twice. But then when you get down to the final stage, you do the same thing. You either look for a GCF, you try to factor that trinomial, or you do the quadratic formula, right? It's interesting now that we're getting to the stage where all the previous stuff we've done, we're still using, aren't we? Well, that's going to work that way right to the end of the course. The stuff you're learning now, you will just keep using and using and using, all the way to the end. Okay? So you guys have the rest of it. What do you got, 20 minutes to start? Please start on the assignment. And then tomorrow we'll do the work period. Hang on a sec.